In the last video, we have discussed the working rule for finding the sum or subtraction of two fuzzy numbers, and we have considered one example for how to add two fuzzy numbers. Now in this video, we will consider one example on subtraction of two fuzzy numbers. Learning outcome: at the end of this session, students will be able to find the fuzzy numbers a plus b and a minus b. Pause this video and calculate the subtraction of these two closed intervals. I hope that all of you have calculated the subtraction of these two closed intervals. This is the subtraction of closed intervals, and we know that the subtraction of closed intervals is given like from the initial point we have to subtract the end point of a second interval, that is 1 minus 6 comma, and from the end point we have to subtract the initial point, that is 5 minus of this initial point is minus 3, so we get 1 minus 6 is minus 5, and 5 minus plus 3, we get it as 8. Now this is the required subtraction of these two closed intervals. Let us consider first example. Let a and b be the fuzzy numbers given by the membership functions like this. Then calculate a fuzzy number a minus b. Solution: step number 1 is finding the alpha cuts of these two fuzzy sets. First of all, writing the definition of alpha cut of a. Now this is the definition. The first range for the fuzzy number a is minus 3 less than or equal to x less than or equal to 0. In this range, we want a of x greater than or equal to alpha. A of x in this range defined like x plus 3 upon 3 greater than or equal to alpha. And writing the restriction for x, we get it as x greater than or equal to 3 alpha minus 3. Next range for the fuzzy set a is 0 less than x less than or equal to 3. And in this range, we want a of x greater than or equal to alpha, and a of x is defined like 3 minus x upon 3 greater than or equal to alpha. Writing the restriction for x, we get it as x less than or equal to 3 minus 3 alpha. Therefore, finally, alpha cut of a is equal to x is greater than or equal to this quantity, means 3 alpha minus 3 will be the initial point, and x is less than or equal to 3 minus 3 alpha means it will be the end point for this alpha cut of a, and alpha belongs to open 0 comma closed 1. Now next, finding the alpha cut of b. Now it is its definition. The first step, its range is 2 less than or equal to x, x less than or equal to 4. Now we want b of x greater than or equal to alpha. B of x is defined in this range as x minus 2 upon 2 greater than or equal to alpha. Writing the restriction for x, we get it as x greater than or equal to 2 alpha plus 2. And the next range is 4 less than x less than or equal to 6. In this range, consider the restriction b of x greater than or equal to alpha. B of x is defined in this range as 6 minus x upon 2 greater than or equal to alpha. And writing the restriction for x from this relation, we get it as x less than or equal to 6 minus 2 alpha. Therefore, finally, alpha cut of b is equal to, as x is greater than or equal to 2 alpha plus 2, it will be the initial point, and x is less than or equal to 6 minus 2 alpha means it will be the end point, and alpha belongs to open 0 to closed 1. Now the next step is applying decomposition theorem for subtraction. Alpha cut of a minus b is equal to alpha cut of a minus alpha cut of b. Now writing their expressions, we get this new expression. Now here we have to perform the subtraction. The subtraction is performed from the initial point 2 alpha minus 1, we have to subtract the end point 5 minus 2 alpha, comma, and from the end point 3 minus 2 alpha, we have to subtract the initial point of the next interval, that is 2 alpha plus 1. Now subtracting 2 alpha minus 12 plus 2 alpha is 4 alpha, minus 1 minus 5 is minus 6, comma, 3 minus 1 is 2, and minus 2 alpha will be minus 4 alpha, comma, alpha belongs to open 0 comma closed 1. Now the last step is finding the membership function with the help of this alpha cut of a minus b. The initial point of this alpha cut is 4 alpha minus 6, equating it to the variable x. Now, finding the value of alpha in terms of x, we get it as alpha is equal to x plus 6 upon 4. Now, this will be the first step for the membership function of a minus b. To find out the range for which it is defined, let me substitute the value of alpha as 0. Then we will get x as minus 6, and substituting alpha equal to 1 here, we get it as 4 minus 6, that is minus 2. Now these are the required 2 points. Therefore, we can define one of the step for the membership function of a minus b as x plus 6 upon 4. Here the smaller number is minus 6, where therefore we can write it in the left side minus 6 less than or equal to x less than or equal to minus 2. Call it as equation number 1. The next endpoint is 2 minus 4 alpha, equating it to x. Again, obtaining alpha in terms of x, we get it as alpha is equal to 2 minus x divided by 4. This will be the next step for the membership function of a minus b. To find out the range again, let me substitute alpha equal to 0 here. If you put alpha 0, we will get the value of x as 2. And again, substituting the value of alpha as 1 here, we get it as 2 minus 4, that is x equal to minus 2. Therefore, the next step for the membership function of a minus b is 2 minus x upon 4. The smaller number is minus 2, but minus 2 already included. Therefore, we can write here strict inequality strictly less than x less than or equal to 2. Call it as equation number 2. Now writing the whole membership function for a minus b using 1 and 2, we get here a minus b of x is equal to x plus 6 upon 4, where minus 6 less than or equal to x, x less than or equal to minus 2, and 2 minus x upon 4 for minus 2 less than x, x less than or equal to 2, and for the remaining range before minus 6 and after 2, the gradation will be 0. Now this is the required membership function.